everyone, and welcome to the Learning Curve. In this video, I will be looking at Caribbean Examination Council's CSEC past paper question samples. And in this question, we are told that the graph below represents a function in the form ax squared plus bx plus c, which is a quadratic. This is the standard form for a quadratic function. So essentially, this graph represents the graph of a quadratic function, which is a parabola. Graphs that take this smooth U shape, be it upwards or downwards, represents a parabola. So here we're given this parabola, which is the graph of a quadratic function, which is a function that takes the form f of x equals ax squared plus bx plus c. And we're asked these questions to use the graph above to determine 1. The value of fx when x is equal to 0. In other words, what we're being asked to find here is the value of y. Fx is the same as y. F of x is the same as y. So essentially we're asked to find the value of y, which is the same as f of x, when x is equal to 0, using the graph. So what we do is that we go to the axis, x-axis here, and identify 0, and go up from 0 and identify the corresponding y value, which here is 3. That is also the y-intercept of the graph. So the answer here, the value of y when x is 0 is 3. So y is equal to 3, and that's the answer. Y is equal to 3 when x is 0. So basically what we did here was to just go to 0 at the origin. That's where the x value of 0 would be, and also the y value of 0. And then we go upwards from that value on the y-axis and identify the corresponding y value, which is 3. So that takes care of number 1. Number 2, we are asked to determine the values of x when f of x is equal to 0. In other words, here we're asked to find the x values when y is equal to 0. So find the x values when y, which is f of x, is equal to 0. So where f of x or y is equal to 0 would be here, right here on at the origin. That's where both x and y are equal to 0. In this case, we're asked to find the values of x when y is equal to 0. So when y is equal to 0, we basically just need to locate the x-intercepts. There's an x-intercept here at -3. And there's also an x-intercept midway between 0 and 1, which is half, or 0.5. So the answer, what are the values of x when y is equal to 0, would be x equals -3 and x equals 0.5. Those are the x-intercepts. The x-intercepts occur when y is equal to 0, and the y-intercept occurs where x is equal to 0. So this is x equals 0.5 and x equals -3. So here's where y is equal to 0, and when y is equal to 0, the corresponding x values here are 0.5 and -3. Since the curve intercepts the x-axis at 2 points, which is commonly the case for quadratic functions which have a real solution. So that takes care of this 2-mark question. Then in number 3, we're asked to write the coordinates of the maximum point of the parabola. That is the graph here. The maximum point occurs here. And that's the highest point in the function. It's the highest point of the graph. So we call that the maximum point. When there's a maximum point, the graph turns downwards like this. And when there's a minimum point like this, it goes upwards. So in this case, we're asked to identify the maximum point. And so to identify the maximum point here, I go to the x-coordinate and y-coordinate that corresponds to this point. So let's go down from that maximum point to locate the x value. Let's keep the line as straight as possible that we're plotting here from that maximum point. And we realize that that maximum point corresponds to this x value right here. Now, what we notice here is that each of the squares, we need to count the number of squares in between two numbers in order to determine how much a particular square is worth. For example, this is 1, 2, 3, 4, 5 squares. So there are 5 squares in between each number. So since there are 5 squares in between each number, it means that each square is worth 0.2. For example, this will be negative 1.2 here, then negative 1.4, then negative 1.6, then negative 1.8, and then negative 2. It means, therefore, that in between this point, which is in between negative 1.2 and negative 1.4, will be negative 1.3. So the x value right here would be negative 1.3, and negative 1.3 is going up to a y value of 6. Okay? So this right here is negative 1.3. So negative 1.3 corresponds to a corresponding y value here. This corresponding y value is really just slightly above 6. So let's be absolutely precise. It's slightly above 6. So if we're going to be very precise about this, right here, it's slightly above 6, and which corresponds to this point right here, just above 6, which would be 6.1. Because this line right here would be 6.2, because we remember that each box represents 0.2. Each square between each number represents 0.2, and since this is midway in between 6 and the first square right here, the end of the first square here, this would be 6.1. Okay? So that corresponds to this maximum point right here on the parabola. So the coordinates of the maximum points would therefore be negative 1.3, which is the x value for that maximum point, and also 6.1, which is the y value for that maximum point. So this is x and this is y. Okay, so those will be the most precise answers. That takes care of that 2 marks for number 3. Now going to number 4. We're asked to determine the equation of the axis of symmetry. Now it turns out that the axis of symmetry is this same point here, this same line that divides the parabola into 2 equal halves. See, the same line that corresponds to the maximum point coming down here is the line of symmetry. So the line that corresponds to the highest point or lowest point, if it was shaped differently like this, the line that corresponds to that point is the line of symmetry or axis of symmetry. Because this axis of symmetry divides the parabola into 2 equal halves. So if you were to fold the parabola around this point, they would fit perfectly on each other. Each side would fit perfectly on each other. So the equation of the line of symmetry is a line that passes through the x-axis. The equation of lines that cut the x-axis or pass through the x-axis are expressed in terms of x. So this would be x equals negative 1.3. That is the equation of the line of symmetry. X equals negative 1.3. And that takes care of this additional 2 marks. Now we're asked to find the values of x when f of x is equal to 5. Okay, so I'm just going to tidy up this chart a little bit. Recall that f of x is the same as y. Never forget that. F of x is the same as y. Okay, f of x is the same as y. So basically we're asked to find the value of, here it says, we're asked to find the value of x when y is equal to 5. That's essentially what we're asked to find. Find the value of x when y is equal to 5. Okay, so where's y equal to 5? Y is equal to 5 right here. So it's going to be values of x. So y is equal to 5 here. So what I'm going to do is that I'm going to cut across to the curve, and we realize that the curve is intercepted at 2 points. It's intercepted right here, corresponding to the y value of 5. It's intercepted right here, which is an x value of 2. So we know one of the x values is x equals -2, rather, -2. And let's determine the other x value. The other x value would be x equal here, this point. So let's go down this point as straight as possible. We're going to go down to see where it hits the x-axis. And wherever it hits the x-axis would be the other x value that corresponds to 5. And this is exactly midway between -1 and 0. So that x value is therefore -0.5 or -half. So the other x value is -0.5. And that takes care of this additional question. Now for the final question in this illustration, this past paper question, question 5, it says the interval within which we should determine the interval within which x lies when f of x is greater than 5. And write the answer in intercept form, which is this form here. X is greater than a but less than b. So where is f of x or y greater than 5? F of x or y is greater than 5 for this portion of values, right? So this area is what we're looking at. This is the area of the curve. This is the area of the curve where f of x or y is greater than 5. And you realize that that area, the area, or rather the x values that correspond to this area where y is greater than 5. The area on the x-axis, or the range of x values, the set of x values that corresponds to that area where y is greater than 5 would be this piece of the curve here. And this piece of the curve corresponds to x values of -2 and -0.5. And so the answer would be x greater than -0.5, put the lower number to the left, but less than, this greater than lower number would be, the lower number here would be -2, because we're dealing with the interval -2 to -0.5. So putting the lower number to the left, we say x is greater than -2, but less than -0.5. Remember that -0.5 is greater than -2. So that represents the interval right here between -2 and -0.5. So x is greater than -2, but less than -0.5, which is the set of x values here, which corresponds to the area where y-axis is greater than 5. That covers the entire area. From here upwards is where the y value is greater than 5. And the corresponding x values for that area of the curve where y is greater than 5 would be this entire area between -2 and -0.5. Excluding -2 and excluding -0.5, which is why we don't use or equal to in these inequalities. And so that takes care of the problem. Thank you for tuning in. I hope you found this lesson to be very easy to follow and straightforward as we continue our series in covering a range of topics in mathematics, including the review of common past paper questions in Popular examinations like the Caribbean Examination Council CSEC and Cape examinations, as well as examinations administered in the United States, such as SAT, GRE, and ACT examinations. Thank you for tuning in. See you soon. Remember to like, share, and subscribe. Thank you.